still are stumped by the W on the yardstick, or you're still stumped by dropping a fish, or you're still stumped by how to create fire. For me, that's the part I don't really like to talk about science, because it almost seems like science is so broad for the globalists. It kind of means whatever they want. It's turned into almost a political discussion.
We are under no obligation to understand things flat earthers refuse to explain.
Well, I'll explain it. So the fish, right? When you drop the fish, you see it goes down 90 degrees to parallel. And you can drop the fish too, where you're at. And we can compare our 90 degrees to parallel and say, down is down wherever you go.
That is just childish, moronic thinking, and you know it.
But you don't understand it? Is it?
Yeah, you're saying things fall because they fall. You're using an observation as an explanation.
No, I've seen things fall in the world. Now I can make things fall, and basically
why do they have weight? Why does the weight change under certain circumstances?
Yeah, that's where you change and manipulate variables. Like I said, if you take the fish and drop the fish in water, what happens?
Its weight stays the same.
Or it swims away, right?
Its weight stayed the same.
What if it's a dead fish?
Yeah, if it's a dead fish, it goes up then, right? It'll go up to the surface, belly up. But if I drop a fish on land, it just drops to the ground and flops around.
Doesn't a dead fish on land go up?
It kind of does the same thing, right? It just drops and falls to the ground.
So why are we talking about dropping a fish? I kind of missed that.
Well, the idea that somehow I'm trying to go back to the very basic ideas of science. So then once we're able to agree that science is about manipulating variables to determine cause and effect, then we can start branching out from like who is denying the science and who is actually following the science.
Not flat earthers.
Your approach is valiant, Grit, but you're so hilariously completely off the rails on every single point that you're trying to make. Like, seriously, for example, when you suggest that you can dig under the fish a hole deep enough that the fish will float upwards, and you think that's science. And then you think, how can we globalists build complicated scientific theories when we don't even understand your fish? Well, you don't understand your own fish. You don't even know that suggesting that digging a hole under a fish doesn't make it float.
Only a moron like Laurie would have just made that comment.
Yeah, this is what I've been told. Okay, I never
you
said
can sit down.
Okay, this is basically what I was told. It was I think Chaiki told me this. That if you dug deep enough underground, up will become down and down will become up. That you could actually, the deeper you dig underground, you would start weighing less and less as you dig down, because the mass above you would be lifting you up.
So would they, let's say I have a fish in my hand and I dig a hole under it, and let's say it goes to the hypothetical center of the earth, and we don't need to pose any shape. We can assume whatever shape, but we dig a hole to the center of the earth. If I don't move the fish, will the fish float, as far as you understand it?
I missed the first part. Say again.
So the fish is in my hand, I dig a hole under it, and that hole is deep enough. Will the fish float, according to your understanding?
Yeah, well, no, I would say that the fish will always drop downwards, no matter where you are or how deep of a hole you dig. Because I've dug holes, I'm saying, how deep of a hole would you have to dig? And that's where Chaiki told me he doesn't know. That somehow you just would have to dig a hole deep enough. I'm like, how many miles? Because humanity's dug down like 8 miles or something like that, right? Like the super borehole, whatever it is. Like, if you were to drop something down there, does its weight start to change as it drops? Like, eventually, is there a point where there's enough earth above the object that mass attracts mass now, and it moves the other direction?
So apparently, what Chaiki said, there's actually some sense to it, but the version that you said before, that we can just dig a hole under a fish and make it float.
Yeah, I was talking about like if you took the fish under the ground and you were deep enough You're like Journey to the Center of the Earth type thing. Like at some point they would dig so far into the earth that they would be going the wrong way at that point. They would actually be digging up instead of digging down.
Yeah, so Crit, you're a flat earther, right?
Yeah.
Do you know that like obstruction of distant objects by the ocean proves the earth is not flat?
Yeah, I'd like to, yeah, sure, if you want to talk about that. I would say that would be kind of interesting because there's a geometric claim there. But as you know, that a geometric test cannot be applied to the earth because the earth has an atmosphere. So as soon as you try to apply a geometric test to earth, there's a problem because there's an uncontrolled variable, quote unquote atmosphere or the air, and the number of the water content in the air. And people have shown that you can actually manipulate the way water and light travels through by adding sugar. You can see, like, you can point to like a laser pointer through a fish tank and show that this will bend the way light works through the same medium. So I would have to say that you'd have to do this geometric test, there'd have to be a way of, like with infrared, if you will, like an infrared camera would factor out atmosphere distortions. And then if you do that, you've got people taking pictures like hundreds of miles. And that's a problem to me because that seems like there is no geometric block to the earth.
But do you agree that light bends downwards as it goes through the atmosphere generally?
Well, they say it bends upwards too. So it's kind of like a
but generally it bends downwards. Do you agree with that?
I don't know. I really don't. I haven't really. Okay. My experimentation with light is more about light attenuation, like how far away a certain amount of lumen can be seen in certain conditions. So as far as light bending, I've seen some things about this, but I've never done any experimentation with light bending. I mean, if you've got
okay, do you know?
Do you have an experiment? Have you done this?
Well, it's a fact that light bends downwards generally as it goes through the atmosphere. Like on a usual day, it'll be bending downwards.
What I've seen is like when I used to do bow hunting of catfish when I was like a teenager. And how you would do this is you try to line your firing arm with the sun. So you try to bring your little swift boat around. You'd line your firing arm with the sun. You point at the fish, and then drop down about 2 inches into the left. And that's the only time I really thought about light bending. Because if you just shoot right where you see the fish, it's not actually there. It's being moved, because of the way the light hits the water, the way that your eyes and the way the sunlight hits. And if you don't line yourself up with the sun, it's almost like a complete shot in the dark. You'll see a catfish, but it could be really any direction at that point because you're seeing its incident and you're also seeing the light hit it. But when you shoot the arrow, it could be like a couple inches either direction at that point.
You got to shoot the arrow below where the fish appears, right?
Yeah, 2 inches down to the right. So
so light bends through the atmosphere in kind of the same way. Light bends towards the denser medium, and it's the way it's commonly said.
Yeah, if I could maybe if I could draw a picture. Have you done carp hunting with a bow before?
No.
Okay, so here I'll draw a quick picture real quick to show you what I'm talking about.
So why is he comparing that interface change of air to water to looking through the atmosphere?
Because it's the same when it's the same thing.
How is it the same thing? The atmosphere is one medium.
Well, the atmosphere is a medium gradient.
Yes, a medium gradient. It's not the same thing as a sudden interface change, like a prism.
But you can what you can do is approximate the atmosphere as a series of mediums stacked on top of each other.
And what does that tell you?
It tells you that light bends downwards as it goes through the atmosphere.
Slightly, correct?
Yeah, just slightly.
Yeah. So doesn't really help their position, does it?
No, it doesn't help. It doesn't help the flat Earth position, no, because if the Earth were flat, you would see distant objects. Like that's my whole point.
Well, if the Earth was flat, you'd be able to zoom in on the sun at sunset and bring it back.
Yeah, exactly. Yeah.
You can't do that.
Crickets.
Yeah, I'm wondering does Crit realize?
Yeah, I'm drawing the picture. I'll show you what I'm talking about.
I can't wait for your picture, Crit.
Okay.
No, I'm just saying, like, I'm excited to see your picture.
Yeah, I'm hurrying.
Is that sarcasm, Andy?
I mean,
me?
Like, if you look at his other pictures, I just like his pictures.
Yes or no, please. Permission to treat the witness as hostile, Your Honor.
I'm excited for entertainment value.
Well, good. That's one thing that will come from this. If anything, at least you'll be entertained. You know.
Kosho, what's up?
Is he trying to explain how refraction affects fishing?
Yeah, that's kind of where I'm going with this.
Kind of like the picture I already put.
One second.
Give flat earther a fish, get entertainment for hours.
Yeah, just ignore that heliocentric model. It offers nothing.
Except for working explanations. But, we don't care about that.
I'm not a heliocentrist, but I'm still a glober.
We don't live on a model, by the way.
What do you say to me? I'm a geocentric glober.
Bastard.
So, are you addressing me when you say heliocentrist? Or do you really mean like people who understand that the Earth is a globe and not heliocentrist?
Please don't go down this rabbit hole curved. We went through it already.
It's the same old fucking thing.
We want to get it there.
Curved. There was one point when
here it comes.
Flat Earther and heliocentric.
It's coming, people.
All right, here we go. You ready?
That gif is so useless.
This is how you do this.
That's beautiful.
So this is like me on the boat, right? And I want to have my back, but I didn't really draw it. My right arm should be up, as I'm aiming. So then I see the fish where the dot is, but instead I drop 2 inches down and then to the right. There we go. Terman did it. That's a good one, Terman. Thank you. That's exactly what I was trying to say there. See, right there.
He posted that like a while ago.
Oh, yeah. I was busy drawing it, too.
I know. I understand what happened.
Okay. See, it's also, too, being able to explain my ideas and say, like, hey, I can kind of draw this out. But, yeah, that's exactly what I'm looking at here.
Why does the red line extend to the sun?
Oh, because you want to line up your shot with the sun. Because if you do this any other direction, that fish could be really any way. You see, if the guy changes his position, say if he moves to his right like 10 yards or something like that, and the sun would then push the fish further away. You got to line up with the sun. That way, that the way the light will bend will show you right where you aim the.
You can only hunt fish with the sun at your back.
No, you can take a shot that if you get more experienced, or sometimes too, like people will see like the way if the fish breaks the surface. Because carp are kind of dumb, So if you throw like a breadcrumb on the surface, sometimes they'll come up and eat it, and you just shoot it as soon as it breaks the surface, and it's it doesn't even really have any idea what's about to happen to it.
Are carp as dumb as flat earthers?
Yeah, I guess so. You could say that if you want to.
Okay, we'll quote you on it.
Yeah, I mean, like if that's what you want to go, if that's how you want to plant your flag on science, that Anyone you disagree with is a carp. You know, because I would say, like, what's the difference between a carp and a girl from Wisconsin?
The amount of curves.
No, one has whiskers. Theirs smells like a fish.
That is so disgusting. I'm never going to Wisconsin.
It's actually scary how much
Did I laugh?
Von Helton. It really does. Hold on, I'll get. For people who don't know who the Von is.
See, the thing here is, like, a lot of people like to use words. This idea, what I talked about earlier, about the dehumanization of just changing people to animals, and yeah, they want to be like dumb as a carp. I gotcha.
Fine.
You know, Crit, do you realize that light bends down generally as it goes through the atmosphere? Like, do you accept that as a fact?
Yeah, do you have an experiment?
Well, you can just work it out through, because you know the atmospheric density decreases as elevation increases, so you can work out with Snell's law that light would bend downwards as it goes through the atmosphere.
Well, here I got an observation for you. So, do you guys know about Mount Everest and then that Mount Chumzo?
What's that? Never heard of it.
Okay, so it's basically in Tyson's book.
Sarcasm.
Oh, okay, I gotcha. It's hard to judge sarcasm because it seems like you want to do this for entertainment purposes, and that's kind of an alien concept for me.
Jesus Christ, Chris.
Okay, well, you see how my name is lighting up there, that Damon E guy? So, like, just automatically assume sarcasm when you see that light up.
I gotcha. So when I heard Tyson talk, that he said Mount Everest isn't the tallest mountain in the world anymore, or not anymore. He basically said, here it is, right? This mountain in Ecuador is actually taller because you're measuring the height of the mountain from, like, the quote he said was the exact center of the earth. So I'm like, okay, well, sure, that sounds good. So you've got one mountain is actually taller, even though it's like 9,000 feet shorter from sea level. But then
two mountains that are taller.
Yeah, but the problem is if you test the density of air, or the pressure, that you're going to see that Mount Everest has a lower pressure. Now that's a problem because it's actually closer to the center of the earth. So if mass attracts mass, and mass is per container, that's a solid debunk right there.
Oh, great.
Which is higher above sea level. Are you kidding me?
Think about it, right?
Pressure's relative to...
No, the pressure is supposed to be level to the center of mass because mass attracts mass.
Not true.
So true. Well, if everything's being pulled,
does anybody see the error in that thinking?
Yeah, let me get through my thought here, okay? So you've got this idea that everything's being pulled to the center of the earth, and at the same time, gas is being pulled towards the center of the earth too. So the closer you are to the center of the earth, the more directionality or downward bias there is. Then this also is shown as a gas pressure gradient. So then if you've got a mountain that is 9,000 feet further away, why does that mountain have a higher gas pressure gradient?
Because gas pressure only works above sea level. Doesn't work below sea level.
But wouldn't it be a gas attracts mass?
Water. One of those mountains is only on land, and so its height is taken from the surface to the height of the mountain. Another one of those mountains is not all above the land, some of it's below the water. So when they say the height of the mountain is taller, I mean from the bottom of the ocean where the mountain starts up to the height of the mountain is taller than Mount Everest, which goes at higher elevation above sea level. But it's only because the other mountain starts below sea level.
Okay, here, I'll show you the mountains I'm talking about here. This is from Tyson's book here. So, like, here you've got Mount Everest. Yeah, and the other one there, the Chimborazo.
Okay, what I'm trying to get you to agree to ultimately, though, is that, like, the obstruction of distant targets by the ocean proves that the Earth is not flat.
Yeah, you're not counting the atmosphere. Are you?
Yeah, I am.
Okay, so there
Because
we go.
light
These are the
bends
two.
down.
These are the two mountains right here. Chimborazo, the Tyson cited. So they also tell you that the death zone is at 25,000 feet. Anything above 25,000 feet, generally, unless someone's in very great condition and very acclimated to the environment, they'll die. They'll just slowly, their body just runs out of fuel and oxygen. And they slowly, and there's been lots of people, they call Mount Everest the tallest graveyard in the world. So if you've got this other mountain that's actually further away from the source of mass attracts mass, why doesn't it also have a death zone? Wouldn't it at least be no more than about the same deadly as Mount Everest or some of these other mountains that are above the death zone? Here, I'll get a citation for that death zone here in a second.
Yeah, but
What
you've got to
about the
remember
murder
that
horn?
Mount Everest starts on a much higher plateau than Chimborazo, which doesn't. And that plateau affects the weather. And part of this is not just the height, it's also the weather on Everest. That's the problem. That's why K2 is so difficult, because the weather there is generally fucking awful.
Yeah, see right here, they talk about if you get above 26,000 feet, it's got this, millibars of atmospheric pressure, which it kills them. The same thing, like airplanes fly apparently at the same height as Mount Everest.
I think you just disproved Chemo's pressure thing.
Yeah, but that's what I'm saying. That's why flat earthers have different ideas. No one here is going to sit there and just keep regurgitating something they haven't done. I'm going to look at all the data points, not cherry pick what I want to be true, and then just run with it. So if I compare
there pressure at the top of Mount Everest, there's no container.
Yeah, so what you got here is that there's no way that gas is being affected by downward bias based off the center of the Earth. Because if that was the case, you would see this effect elsewhere, even mountains like the Chimborazo. That mountain would also be a death zone, and it's not.
Oh, but did you hear what people are saying? Like the mountain starts below the ocean. That's what people are saying. I don't know if that's true. But
No, it's not. The Chimborazo is on the land. Yeah.
I wasn't talking about the Spanish mountain. I've never heard anybody bring up the Spanish mountain. People.
It's Spanish.
Yeah, people usually
it's Ecuador. It's in Ecuador.
They're part of the Andes range, and it's 10,000 feet lower than Everest. So that's another reason.
Yeah, but astrophysically, it's not 10,000 feet. Astrophysically,
no.
It's actually taller.
No. It's
peak elevation is only 6.
Because the measurement of the mountain, as Kosho so patiently and diligently explained, is taken from sea level, not where the mountain starts.
Yeah, but not unless you're talking astrophysically. If you're talking astrophysically,
what do you mean by astrophysically? Can you unpack?
Yeah, hold on. I'll get a citation for that.
The centroid of the mass of the Earth, the distance from the peak to the centroid of the mass of the Earth.
Oh, I see what he means.
Yeah.
Okay, because it's on one of the bulgy bits. It's a little bit further away, and therefore, technically, it's a little bit higher. No, because again, you're talking about the center of mass and where you are. So it's not higher in reality. It's still that distance above sea level.
Right. It's only 6,200 meters above sea level.
So I was talking about Mount. I think
it also doesn't meet his own criteria for the death zone, which is 8,000 meters above.
Yeah, I mean,
all his arguments are kind of invalid because he keeps using this.
Here's it's like a 4-minute video.
The problem is, Kurt, we don't measure things from the centroid of the center of the Earth. We measure things from sea level.
Yeah.
Right. Well, if you're astrophysically, you'd want
to.
Right, but that's not how it works when you're calculating air pressure.
But correct.
But it would though. If you're using the center of the Earth as a container.
They're doing this.
Oh, sorry. Go ahead.
When they're talking about these death zones, they're talking about experience on the real Earth. This is how they're kind of getting. If you go above here, it's a bit more risky. Or if you go above that height, it's really risky. And by the way, you're better acclimatized. Yeah, I agree with all that. And that's based on observation. They're not taking Neil deGrasse Tyson's argument about a little jokey thing that, oh, by the way, this mountain's on the bulge. You know. And
it's the highest point from the center of the Earth, tallest point above sea level. Those are two different categories.
And
you are confusing them for some reason.
Yeah, I wasn't sure you were referring to this Ecuadorian one or whatever, by the way, which is on the equator. I think, which is probably what his point was, something to do with the how the Earth bulges out right there. But what I'm talking about was Mount Kia. So in the future, that might be a more relevant one for you to. I would never bring this up again, but yeah, the Mount Kia one is the one that starts off below the below the surface of the water and is actually 3,000 feet 3,000 feet taller.
In Hawaii.
And
yeah, you know what? Yeah, it is in Hawaii.
Yeah, I got you too. Because I think at some point Tyson does mention that too. That if you say like Mount Kia is like taller than Everest and it's the tallest mountain in the world.
Base to peak, yes. Base to peak, it is taller than Mount Everest.
Yeah, because if you go all the way underwater.
Yeah.
But if you measure from the center of the Earth, astrophysically, then.
But the only person who does that is Neil deGrasse Tyson.
Yeah, I know, but he's a kind of important figure because he likes
No, he's not.
He likes to drop the
He's a science communicator that tries to get people interested in science. That's all he is. That's all he'll ever be. He's not our freaking saint. He's not he's not our go-to guy for evidence. We don't use him for anything except for, explaining things to the layman to make them interested in science. That's all he does.
Yeah, but this is about entertainment, right? He did go on Comedy Central and he dropped a fake microphone on the ground and said something about the Earth isn't flat and this is gravity. Well, if I test that claim, right? And unless I say it's even just a joke. Like, okay, sure, I've got a scientific experiment here. Instead of a fish, I'm going to use a microphone. And I'm going to drop it on the Comedy Central stage. Will the sound change as I'm dropping it? And it doesn't, because the actual microphone was on his shirt.
Can you show me a USB fish crit?
Yeah, you guys are stumbling over each other again.
Can you show me a USB fish?
Yeah, I don't think you realize what a mic drop is, and it doesn't work very well if you're doing it with one of the lapel mics.
Well,
the whole idea is that when you drop the mic, it's supposed to make a big... Yeah, it's supposed to boom, right? When you drop the mic, it's supposed to make a sound when it hits the ground.
No,
so everyone knows, it's like, yeah, this is the legit mic drop. The legit mic drop is you're talking into it, and you drop it.
He has a different definition even for mic drop.
Yeah, I mean, compared to like Neil deGrasse Tyson mic drop, right? It's supposed to create kind of like an audio chaos. That someone says something, they drop it, and it's like, the mic hits the ground and bounces around and creates a bunch of noise at the end.
That's not really the key to this. That's not the point of a mic drop.
See, you have a different idea of what a mic drop should be, and you're trying to apply it to other people who don't share your idea of what a mic drop should be.
Hold on, I'll get a citation from mic drop. I'll get a citation from mic drop. Don't worry.
It's just supposed to be a double entendre, which is supposed to be the end of his joke, man. It's not.
Exactly.
Yeah, it's just like, here's gravity.
It's just like a highlight to note the end of your statement or your performance or whatever.
Yeah, but you want to make noise when you do it, though.
It has nothing to do with noise. Read the definition. This is what most people mean when they use that word. Again, if they mean something different, they will generally say what they mean. You, however, don't do that.
Not crit. I feel like we did this recently.
Yeah, he's like, you want to talk about science, and we're back to this idea of worrying about words, like even worrying about what mic drop means.
No,
well, because that's why you can never have a conversation about science.
Things that no one else defines them as. It's a problem.
Yeah, here you go. This is a
ineffective communicator, Crit, and there's only one person that can fix that.
Sound if you want to add a mic drop to your video game or something like that. This is what it should sound like.
I'd like to throw a drop kick in somewhere.
Again, so now he's confusing the sound for the definition.
No, this is what the effect is you're going for. Yeah, you're not just going for.
He doesn't know how to define terms and use them. He thinks that
I got to talk about terms again. I know isn't it crazy? Like I try to stay on science.
Can't make a comprehensive.
Okay, yeah. So now let's talk about the mic drop. Okay, how long do we want to talk about the mic drop? Tell me, is it going to be half hour, 45 minutes?
How long? We don't want to talk about it.
Okay, so do you understand when I'm talking about mic drop? I'm talking about someone drops a microphone.
Talking about
connection.
Talking about
to
usage of mic drop that applies only to your experience and no one else.
Mountain. Like, what's the connection to the height of a mountain? Obviously, yes. Neil deGrasse Tyson is the connection. Why is that relevant? It doesn't. It's
okay.
Not.
It goes back to if someone's going to talk astrophysically, and they want to use the gas pressure gradient as their astrophysic proof of a mass attracts mass container, then they would have to show you that astrophysically all points on, like, I guess, pear-shaped perf, right, would have to have the same pressure gradient.
No, we know that the Earth's gravitational field is not uniform. So
It's
an average, right?
Physically now. It's never fucking ending.
It would have to be like this idea
the
of
Earth's gravitational field is not uniform.
It's an average.
So therefore, you are wrong.
No, I know this.
Your argument is ridiculous.
No, I know that a lot of people, a lot of globalists will argue with you, telling you that gravity is a constant when it actually is an average.
Globalist term again.
No.
Not defining.
We know that the gravitational acceleration is not an actual constant.
Not all you guys. Some of them, people out there actually think that gravity
then they're
is
wrong.
a constant.
The people in this room right now know that little g, the gravitational acceleration due to the Earth's gravity, is not a constant.
Okay, well, sure.
It varies.
Yeah, it varies, right? So now you've got another uncontrolled variable when you're playing around with this. So how would you control the variables to make it so that this Mount Chimborazo and Mount Everest, though being maybe the same size or the same distance or roughly close enough, why is there no death zone on Chimborazo?
How many times does it have to be explained to him?
No, I'm asking I'm asking for an explanation. I'm asking for an experiment. What variables would you change and manipulate, man-made or otherwise, to validate that idea?
The peak of Chimborazo is 8,500 feet approximately lower than the peak of Everest.
Not astrophysically, though.
Somebody, Barney Dobbin.
Joshua, will you explain it to him again?
Air pressure only.
Can I ask a clarifying question, please?
Go ahead.
He's talking about, when he talks about the gravitational constant not being constant, you're not talking about big G, right? You're talking about the measurement of
little g.
All right. So, but big G is a constant, right?
Yeah,
by definition.
Yeah. Okay. I just wanted to clear that up. Thank you.
Yeah. So you got two different gravities, one that's a cause and one that's an effect.
No.
Okay. Well, sure. What's your idea of the gravities then? What are they? Are they variables then? Are they like controlled variables, or what are they? Physically speaking, anyway.
Well, big G is a constant. It's a universal constant. It's the same everywhere everywhere at every place.
Okay.
In the universe. Little g isn't. It varies depending on the mass, right?
Yeah. So that would be an effect then. Mass would be the cause. The effect would be little g, and the other way around, you'd have big G would be the cause. The effect would be a downward acceleration. Cause and effect, right?
So people die in Mount Chimborazo. So I'm just letting you know there is a death zone. People die up there.
People die doing dangerous things? Who would have thought?
So how about this experimentation you guys got? You got anything like that, or am I just going to be like
experimentation for what? For what, Crit? I mean, I just got here. I was in.
He wants us to have the Earth's gravitational field as a control variable,
or how you would control it
for atmospheric gradients.
Well, that was determined in Cavendish's experiment, right? He measured the gravitational constant, right?
But specifically use it as a control variable to measure atmospheric gradients to be able to tell the difference between like the gradient in one area compared to the gradient in another area.
Would you be able to use this to get a prediction of of gas pressure?
Yep.
But not.
It
but
would
only
take a really long time and a lot of information, and it would take a huge amount of computing power.
Hey, Crit.
Yes,
do you know who PhD Tony is?
Yeah, I think so. In the server, right? Okay, yeah.
Well, in the community at large, do you know what he does? He teaches, right?
What?
Yeah, I didn't know that part.
And he uses gravimeters with his students, and so in order to detect the gravity, right? You understand that? They have we have instruments called gravimeters. So
I've actually talked about that too. Like, go ahead.
What he does is he'll go on into a field and he'll bury objects, and then his students are tasked with finding them using their gravimeters, if that's pronounced right, and they can do it.
Your gravitometer.
They can do it. They can detect buried things using a
gravimeter. It's just gravimeter.
Yeah, gravimeter. When you're wrong, Crit.
So they can do that. So that would be evidence that the theory is correct, because that would be evidence that would confirm the theory of that masses attract, because we use an instrument to consistently detect the presence of buried objects.
Okay, so what I'd like to see then is using another type of instrument, like a barometer or an altimeter. And then, because actually who got me on this line of thinking...
They don't detect gravity, though.
But they could, astrophysically.
I don't know how they would do that.
Because RC gave me this idea.
So we would need both sets of data, right? We would need to measure the atmospheric gradient at all points on the Earth, and also have the gravitational measurement at all points on the Earth, and then compare the two and see how they correlate with each other. And we'd also need altitude data.
That would be an experiment, though. That would just be like just comparing data. I would say, like, if I gave someone
correlation between the two,
gave someone the mathematical formula, like for Newton, and you wanted to have big G here or little g, depending on which one you wanted to use, or compare the two, and then say, hey, at this altitude, at this location on Earth, the person would predict X atmospheric pressure, and then go there, fly up in a plane or a weather balloon or whatnot, and then actually test the prediction.
Well,
and if it comes back something other than the prediction, that would mean something was would validate the null hypothesis.
No,
that there isn't a direct connection between
taking into account all the factors that affect atmospheric pressure.
Okay, let's do it. What are these controlled variables?
Lots of different things affect
atmospheric controlled variables.
Yeah, a cold front or a warm front could come in, and that changes atmospheric pressure.
Exactly.
For location.
Okay, so we got warm and cold fronts. What can you guys think of some other controlled variables?
Hurricanes and cyclones.
Can we just how about weather? Do we just call it weather then?
Weather's a good one, yes.
Okay. Anything else you can think of?
Daytime, nighttime.
Weather's incredibly hard to. Yeah.
Another one would be
things that affect barometric pressure at any other point on Earth will affect barometric pressure at the top of that mountain.
It could be the giant sucking sound of my soul as I have these conversations.
Really? I thought this was entertaining. I mean,
it was a joke.
Okay. I know. Remember how bad I am at nuance?
Yes.
Okay.
Are you also?
I feel it's like you crushed my soul there. I actually felt sad for a second.
Are you face blind too?
No, I've been called face blind before, just because everyone younger than me just looks younger than me now. So I don't. I just see kids everywhere. It's like.
What the fuck?
Yeah, it's weird. That's why it's like when you get older, everyone just looks young. It's like, yeah, you look young.
Okay.
I don't think that's what Brenda was talking about.
That's correct. That's not what I meant.
Yeah, I know you meant like you see someone's face and it's like a form of autism where they can't tell if someone's what facial expression they're making.
Well, that's not autism, but
that's not what face blind means. It's whether or not you can recognize one face compared to another face.
Well, yeah, I get what you're saying with facial features, but sometimes people do look alike. There are like those issues. So
the whole idea is that atypical definition for face blindness.
He's got his own definition for every fucking thing.
Oh yeah, I've heard about this, and they actually
They also, they won't be able to.
They recognize them by their gait, don't they? Sometimes.
Yeah, because everybody has a unique gait. That's true.
Prosopagnosia.
I got a citation coming in, face blindness and autism, where I got this from. See, instead of me trying to guess what you're saying and just come up with some sort of idea here, just express it. Like, be like, hey, people
whoa, you don't do that. Why should Brenda have to do that?
I do it. I did do that. I did it the whole morning.
This whole morning, you're really talking about this through hoops to figure out what the hell you were saying.
Yeah.
And even the people who thought they understood you were wrong.
Yeah, facial agnosia is what you're actually talking about. You weren't talking about face blindness in itself. Face blindness being people who can't read facial expressions. So here's what I was talking about: face blindness and autism. People who can look at someone and not recognize an angry or a sad face. And they do this with autistic kids. They'll show
a different definition than what Brenda meant.
Right here.
Am I correct, Brenda?
Incoming right now.
Yes.
You wouldn't need to ask if Brenda just
that's right there. So face blindness is a symptom of autism, and this is what I was talking about.
Yeah, but
so
the
when
definition
I hear someone
you just gave about not being able to understand emotional states is not what that word means.
Yeah, well, when you talk about with people with autism, that's exactly what it's talking about.
Well,
this man can't communicate.
I kind of regret even asking the question. It took you off of your subject.
No, it's happened a couple times already.
Because I don't think anyone knew what you meant if it wasn't one of those two things. How about you say what you meant?
We've already gone through this. I'm just regretting bringing it up because it's off topic. We should go back to the topic.
No, because I've heard people talk about a lot of times they like to make these
if I've ever heard one.
No, it's fine. But I like a lot of these jokes where flat Earth people have brain trauma, they're autistic, they suffer strokes, they got neurodegenerative diseases, and that's kind of where I tried to deflect back to something less toxic, and then it still turned into a toxic.
Hold up, Crit. I'm actually genuinely curious what she meant by face blind. If it's not the ability or like the lack of ability to recognize faces or to discern facial expressions, then what the fuck is she talking about?
No, she was talking about the first one.
She's talking about prosopagnosia. What Crit is talking about is something called social emotional agnosia.
Well, he said both
completely different. That has nothing to do. I mean, not nothing, but it's not the same thing. Apples and oranges.
Okay, is that true, Brenda? That's what you meant?
Sure.
Now she's just agreeing to get over it.
Basically,
yes. It just came out of nowhere then.
Basically, I just want to get out of this because it was just a dumb question. And I regret making
No, there's no dumb questions. There's only dumb people.
Well, it was kind of way out of context. I don't see the relevance, but...
Yeah.
Okay, like this. The only dumb question is the one that isn't... Oh, sorry. Go ahead, Brenda.
I'm just trying to form a theory of mind. That's all.
Well, I would say the only dumb question is the one that isn't asked. Because if one person's thinking it and wants to say it, I'm sure there's other people too.
So we agree that atmospheric pressure is not a good way to detect gravity.
Well, no, you would have control for these variables is what you would do.
Why?
You take the same measurement at the same weather conditions. You take the same measurement at the same time of day.
Why don't we just? I know what we should do. What we can control for atmospheric conditions by building a shed, and inside of the shed we hang 300-pound lead weights and we let the weights settle as they're hanging from a string or something like that, and then we wait, and then we bring two other weights in close and see if those lead weights move. How about we do that?
But then now I want to apply that to the atmosphere and gas pressure gradient.
No,
because the topic was how do we measure how tall mountains are?
Oh, fuck me.
Yeah.
You were way off, Brenda.
So then if we go to, basically the person has the same weather condition, controlled variable, and they can also do it at multiple different weather conditions. That way you can control the variable by also testing for all the different conditions that you think would apply, and then testing to see if these conditions did alter the cause and effect relationship. Because there's more. Like a lot of people say you have to, if you control a variable, it must not be present in the experiment. When that's actually quite the opposite. You want your controlled variables present so you can document what happened and what happened with these controlled variables. And sometimes even the controlled variable could turn out to be your effect. You could be like, oh, this is what I was looking for. And I thought it was this, but instead it's actually something else. It was one of these controlled variables, like weather in the example we're talking about now. So someone would go, I think I can predict how high I am based off gas pressure gradient. And it turns out that actually they can predict gas pressure gradient off weather.
I think we would measure that by the amount of THC in your system.
What test do we have to do that, Brenda? Come on.
Cocaine's a hell of a drug. So basically, at the end of the day, I've given you guys lots of ideas of experiments that I've done. And what I'm looking for is I've shown you mine.
Whoa.
Is anyone going to show me yours? Yeah.
Which experiment did you do about this mountain height thing?
No, I never said experiment there. I talked to you about the fish, the
So
W.
you've done these experiments.
Yeah, the fish and the W, right? The ambient light in the atmosphere. And I also did the one where you can drop objects in different mediums and see what happens, which way they go. So if I'm going to say, like, a lot of times people tell me that you can tell the Earth is a closed system by how open it is. So, like, sure, let's look at that, right? Like the gas pressure gradient. So you got a gas pressure gradient. Can you use astrophysics definitions of the core of the Earth and the distance from the core with some sort of controlled variables and predict gas pressure gradient? Or is it just kind of observed and there's no model of prediction for that?
It's a model of prediction, but it's an average model of prediction. It doesn't give you a prediction for every point on Earth, and it's not 100% accurate for every point on Earth because it's an average. But yes, we do have a predictive model that predicts atmospheric gradient, but it's based off of elevation.
Yeah, elevation off sea level or elevation off the core of the Earth?
I'd have to look it up. I haven't seen it.
Above sea level, because there's no air pressure below the water.
Yeah, but there'd be gravity below the water or the sea level.
So what? You're asking specifically for air pressure.
Yeah, great. I linked a simulation the guy did with gas particles under the effect of gravity, and it showed how you get a gas pressure gradient. I linked it at 28 minutes past the hour.
Okay, thanks. I'll check that out. Because I would then want to validate that through experimentation. So maybe I can pull out some stuff out there and come up with a hypothesis and experiment.
Well, what's the real question here, Crit? Is it about
no? It's about experimentation. I was just picking up because Chemo was talking to you guys about experiments and stuff.
Yeah.
Well, what do you want to experiment on?
The natural world.
Specifically, you're talking about Everest and Chimborazo. Is this in relationship to what you want to experiment on?
No, I would not want to experiment on any sort of high mountain peak. That's like beyond my forte.
Have you left the Chimborazo Everest air pressure differential discussion, and you're on to something else?
We can still talk about that if you want. What do you got? What are you thinking, Curves?
I'm trying to find out what you're getting at, and it can't be done.
I'm lost too.
Okay, here. I'll tell you why I'm stepping in here. So, say you could hypothetically build an altimeter or a barometer that actually measured all the way to the core of the Earth. It was picking up a version of gravity that could get you a predictable outcome of air pressure gradient.
Barometers do.
The barometer measures
air pressure. Yeah.
So you've got to take a direct measurement. He's arguing you should take some other measurement to approximate the measurement you actually want.
Yeah.
Why would you do that?
Basically, science. You do that because of science.
I have a word here.
Oh yeah, go ahead.
Now, what you'd get if you did that, drilled a hole to the center of the Earth and lowered your pressure thing there, would just be a taller column of air, and the exponential gradient that we already have in the atmosphere would just go on
No,
upwards
something
to
something
some
weird
insane high rate.
happens.
Shut up as I'm speaking.
I'm sorry.
It would just go up to some higher pressure down there. It would still be exponential. Now, you're actually right about the distance to the sensor should be what you used, but seeing as the variation would be so very small, we just use elevation.
Is Sort really quiet for anyone else?
No, I can hear him.
I'm really trying to shout at the damn mic.
Yeah, I got you because I see what you're saying here because you can't use the distance to the core of the Earth as your controlled variable because the variation is too little. It'd be an uncontrolled variable because at that point they would throw off your experiment so little that it wouldn't matter at that point.
Yeah. The variation of that whole pear shaped thing, right? It's gonna be in like 50 meters or something. It's not gonna be some huge number in elevation.
Yeah, one time I did an experiment here with some friends about like beer and stuff, like for like drinking beer and how many beers you could drink, and we kind of basically did a DWI thing, but we did a DWI thing with a dexterity game. But
sounds illegal.
No, we weren't driving. I said we're playing a dexterity game.
What was your control?
DWI, is it?
Yeah, the control was alcohol content, but you could also say that if you were to measure every milliliter of beer, right? It wouldn't be a very good controlled variable because it's not going to throw it off. Like if one beer bottle is 253 milliliters and the other beer bottle just happens to be 254, that 1 milliliter won't throw off the results that much.
That doesn't sound like your control. That sounds like your variable.
Yeah, but you call it an uncontrolled variable because you're just you're not counting your variables out by milliliter.
So what was your control then?
The control is alcohol content.
That's not a control. That's the variable, not the control.
No, the amount of alcohol was the.
So you got a control for that. So you got to have one of you who doesn't drink anything.
No, yeah, you did the test before and after, and then also during to see how much alcohol affected you. There's a way. Okay, basically what we did. Okay, the long story short, it was a lot of fun because we turned board gaming into a drinking game, and then kind of had fun with it.
I have suspicions that it was not really a very rigorous experiment.
Well, yeah, and I will agree with that. It wasn't very rigorous, and it was actually kind of fun, which is what science should be. Should be a lot of fun. Should be entertaining. That's kind of where I keep trying to direct the conversation back to science. Because this idea about shit talking people on the internet shouldn't be fun. That's like TMZ, BuzzFeed style. Number one, list of top 10. Number one will surprise you. That seems, in my point of view, it's like really silly.
Cyberbullying. Dude, like the thing is, I mean, if you've been around for as long as some of us have, then you know that these debates get very, very, very fucking tedious and repetitive very quickly. Also, I have no doubt that anything you bring up here, Crit, before it's probably been explained to you before several times. But you continue, to hold your positions, despite these things being explained to you numerous times.
Yeah, I'm not looking for explanations anymore.
Right. Well, I mean, okay, but still, like, so the whole TMZ thing, comments you're making, like, there's really nothing else in flat Earth, as far as I'm concerned, than is pure entertainment, right? It's fucking lol's cow. Like I said before, it's a lol's delivery mechanism, as far as I'm concerned.
What are you looking for? Sorry, I thought you'd done.
Oh no. So like I'm yeah. Okay, that's that. Yeah, I'm done.
Well, Crit, you're not looking for explanations. You just said. So unless I misunderstood you, what are you looking for then?
Science.
Looking for what?
Just testing models and testing the natural world.
We're looking for Bill curved. We're looking for Bill Nye.
Well, one science is Blue Marble Science redid the Cavendish experiment and showed that his results were consistent with previous results. So, what do you think of that?
I'm not sure. I guess they tell me to comment on an experiment that I have no idea about. I would say, what do you think of that?
I think it confirms what we've all been saying, which is that gravity has such and such a force, and it can be measured experimentally, by anybody with sufficient knowledge of how to set it up. And that's what Blue Marble Science did. That's what engineering students do in almost every university every year. Is they repeat the Cavendish experiment
twice a year.
And they get similar results to those of Cavendish and all other scientists have in the intervening years.
Okay, turn that down. So basically, your observation would have been gravity is a force that can be experimented with such and such. And I would agree with you. That's why I was talking about the gas gradient. I wanted to kind of maybe play around with this, or maybe get some sort of working hypothesis, and maybe ask somebody like, hey, how would you measure gas pressure gradient using gravity as a force with such and such?
Yeah, you're not going to do that.
How would you measure gas pressure with gravity? You're not just measuring it directly.
Yeah, gas pressure gradient.
You just measure gas pressure with a barometer. That's what you. Why would you use gravity?
Because gravity is being called the container, quote unquote.
Yeah.
Well, it's a containment. Yes.
Okay, that's exactly what I'm trying to get to with this. So we have an observation here that mass attracts mass, and that gravity can be a downward bias or downward force, depending on which version you're kind of using. Not you, okay? If I make sure when I'm saying you, it's not directed at any individual, okay? That a person is trying to validate this downward bias in creation. So using that idea, is there a way to one-on-one correlate cause and effect gravity and gas pressure gradient?
Why did you say creation in there? That's confusing.
Yeah, well, this is the Earth, right? Not natural world. I'm not.
That would be a better term, because when you say creation, that's confusing.
Okay, the natural world. I'm not trying to evaluate the supernatural here.
So according to according to even Newton's theory, as well as Einstein's, gravity is a result of, in Newton's case, a force of attraction. In Einstein's case, it's the bending of space-time, but it mimics Newton's. Is that anything with mass will be affected in such and such a way due to the phenomenon we call gravity. The atmosphere, gas molecules have mass, so they will be affected by it.
Yeah, there's a problem I have here is I look up, Newton said he didn't feign any hypothesis.
That's correct. You're right. You're right. He didn't have a theory of gravity. What he had were laws of gravity.
Yeah, so if I were to try to validate, natural law, right? You can just either say it is or it isn't. It doesn't need to be validated with experimentation. But if you wanted to, through like Cavendish, then there should be other ways of validating natural law in any sort of controlled environment.
Laws are established by repeated observation. So you understand, even Quantum Racer and Nathan Oakley get this correct. Laws are established by observations, right? Theories are the result of repeated experiments, and they are intended to explain those results. Newton didn't try to explain gravity. He simply said what it was. And here are the laws that govern.
And he was 100% wrong about it, Brenda.
Here are the theories.
He was 100%
Here are
wrong.
the laws. Here are the laws that govern the phenomenon we call gravity. And then Einstein came along and gave a theory that accounts for why the phenomenon that occurs takes place. So that's the thing. Right? We get that now?
Was that
Did
for
you get
me
that,
or
Brenda?
Was that from me or
Newton
SE?
was wrong, and you are wrong as well. Did you catch that?
No,
Oh,
Yeah, I
God.
heard you. I heard you.
Newton was right because.
Hey, Crit, did you actually read that paper that you posted a link to?
Yeah.
What was the point of the paper?
The point of the paper was when they're basically. Here,
Was
one
it
second.
against hypotheses?
No, basically the point of the paper was saying that when teachers are in high school are talking about the scientific method, they seem to try to roky-doke Newton into that, even though Newton said he doesn't have a hypothesis. So it's kind of like people find out later on when they're learning about scientific modeling and stuff like that, that they kind of have to find this out on their own, that this wasn't presented appropriately the first time, using like the physical sciences in high school, if you will. And it generally had to do more with observations using a long or deep space telescope than actual experimentation that would have been done in high school.
So, Crick, can I ask you a question?
Yeah, certainly.
Well,
Anything you want.
Yeah. So, do you
I don't think this
like?
paper was about.
Do you think gas particles are immune to gravity?
No, I would say that gas particles move freely in all directions, and maybe there is a downward bias to their, to which way they go. And I would like to see that through a gas pressure gradient. That I would say, if you've got some sort of gas pressure gradient and it is being affected by gravity, you should have more gas at the bottom than the top.
Oh, we do. Though.
So
yeah, that's been shown. That's been shown.
Yeah, and then you should be able to experiment with it.
It's been done. Been done, dude. It's been done.
Okay, well, sure. Then what exactly? What I'm looking at here is a observation of these two mountains that it doesn't match the claim, because you've got.
It's been explained to you, Chris.
Astrophysically, one mountain is taller than the other one, but the other mountain has a greater gas pressure gradient than the other one.
I think you're confused on what it means for a mountain to be higher than another mountain.
Well, I was talking about astrophysically. If you're talking with astrophysics instead of actual sea level, because if you do just sea level, then it's kind of back to that observation. I used a measurement of the locks of lake of the St. Lawrence Seaway, and also the Suez and Panama Canal. Because then if you're just measuring sea level on different locations on Earth, now that's a problem, because that is virtually the same. Sea level is always sea level.
What is the problem with that?
Yeah, because there's no curve then. That's a solid.
That's not what sea level means.
Okay, hold on a second. Let me get that stuff.
Sea level simply means that on the spherical Earth, mostly spherical, almost perfectly spherical, but not quite, sea level will the water establishes a mean level, right? It is slightly different in some places for various reasons, but on average, you can take a mean and determine what the average sea level is and measure things from that.
Okay, so here we go. This is what I was looking at when I'm talking about sea level. So you've got this building here at the end of the St. Louis Seaway, a 60-tall building. If you measure that to Lake Superior,
yeah. Do you
now
think
you've got Lake Superior?
Yeah.
Oh, go
do you
ahead.
Do you think rivers are at sea level?
Yeah, this would be the St. Louis River. They basically call it sea level. Well, yeah, this river anyway.
St. Lawrence is, yeah.
Yeah, that's what I'm talking about right now. Do you see the image I posted?
Right. So those are locks, right?
Yeah, these are locks to drop the
Right.
water level all the way down to sea level.
Right. So the water that's behind the Coolidge Dam, right, is not at sea level.
So how would you account for curvature in this model?
Well, we would account for it by the fact that humans built a dam and humans built locks.
Okay, I'm missing what that
You
means.
that point? You don't get that point?
No, so humans built locks and they have curve in the lock? Where is it 8 inches per mile squared here?
What the hell? Do you know that there are locks all down the Mississippi River?
Yeah, can we focus just on this one right now, if you will?
It's a general case. It's a general case. Humans built locks in order to prevent flooding and other things, and to permit shipping on the rivers and stuff to make it easier for us, right? But in the state of nature, without dams and without locks on rivers, they flow downhill, dude.
Okay, how about here? How about Suez Canal then? That's 100 miles with no locks.
The Suez Canal has locks. What are you talking about?
Are you sure about that?
At the ends, it does. At both ends.
Okay, hold on. I might be wrong. I saw a video of it that showed that there is no lock.
So what is it you're trying to claim about the Suez Canal? I could be wrong. Maybe I'm thinking of Panama. I'm thinking.
Yeah, Panama has all kinds of locks. It goes right through a mountain.
Yeah, maybe the Suez doesn't have locks. So what? What's the point?
That where's the curve of the Earth?
What do you mean, where's the curve?
So
that was
got
a simple question. Where's the curve on the Suez Canal?
Well, you would measure it.
It's flat.
You'd
measure it at sea level.
The Suez Canal has no locks because it says here the Mediterranean and the Red Sea have the same level.
Right. So to measure the curvature of the Earth on the Suez Canal, you do just the same as the Bedford level experiment. You get several markers and you space them wide across, a certain distance across, and then you see, you measure, and you will find that the middle marker will be above the two ends. That's the curve.
Yeah. See, what I'm looking at here is if someone could see all the way through, okay, from one end of the Suez Canal to the other side, it would be completely flat.
Completely flat.
What are you talking about? It wouldn't be flat if you measured
it. It's 120 miles. You're not going to see ships 120 miles if you look down the Suez Canal.
No, if you could though, like say if you could just put like a giant stick in the top of one ship or the top of the other ship and measure their heights, they could be
you would see them go over the curve, just like we see in all kinds of other pictures. Ships go over the curve.
Yeah, well, that's not what I'm seeing. I'm seeing sea level. I'm seeing a curve here.
What are you talking about sea level? What is your cognitive dissonance?
He thinks that sea level means flat. Sea level just means equal gravitational potential.
Yeah, it does.
Okay, so now that's right. Okay, so now we're getting to this idea of gravitational potential. So if we did a gas pressure gradient at both locations, it should be the same, right?
I don't know. Probably.
The gas pressure will be more or less the same, yeah, except for the fact that you can have it'll be different temperatures and things in different areas. There could be weather systems that move in that will fluctuate the local pressure, but it'll be fairly close to the same pressure.
Okay, so we're talking about controlled variables again.
So,
right?
do you get the point? Do you get the point about what I said with like the Bedford level type experiment, the one that was also in the Flat Earth documentary? You have 3 points, right, and you have the point in between. If the Earth is flat, it will have one orientation, and if it's curved, that middle marker or the middle piece of cardboard in the documentary will be higher than the two ends. That's the test. And lo and behold, Jeranism proved curvature.
Well, that's not what I saw. I saw basically he was showing that the guy on the one end had to lift his light above his head.
Yes, that was the proof. That's the proof.
No, it's not proof because check it out.
It is.
What if you switch camera and light? Now the other guy's got to lift the camera up, and so that right there shows you that there was topography there. There wasn't curvature.
Presumably, they made allowances for that. So
they didn't though, right? They screwed the experiment up.
No, the fact that he had to lift his light up in order for it to pass through the middle hole proves that there was curvature.
No, that idea there that to pass through the hole though, the one guy had to lift up when he shouldn't have had to. He should have
the proof. No,
it should have been the same level on both sides.
No, that isn't how level works.
Yeah, okay. That's why it's difficult for me to understand if level is curved. Okay, if someone's telling me level is curved, I'm not able to I have cog dis. Okay, I will say if someone tells me level is curved and I can't square that.
Right.
Because to me, level is level and curve is curved.
Yeah, but that's just your problem. That's a you problem, not a us problem.
No, I got you, and now you know why.
It's pretty.
Yes, ma'am. Go ahead. I'm sorry to interrupt you. Go ahead.
It's pretty simple. If you take a basketball, there's only one point on that basketball that's level, right? There's just one point on that basketball. Where if you had really good, like those guys that set the stones on top of stones, if you had a marble that you were going to set on top of a basketball, you understand there's only one point on that basketball that's level where you could set that marble and it won't roll off, right? There's only one point.
Okay, and that's kind of where
if you rotate that basketball, it's going to be a different point on that basketball.
And that's what I'm saying. So black
swan, always going to be in relation to the gravitational vector. And on the globe Earth model, every single point is at the top of the basketball. So you are only level at every single individual point on the surface of the Earth.
So then when I look at black swan, I can apply black swan to that basketball. Why can't it be applied to the Earth? And everyone said, well, it's an atmosphere.
What do you mean you can apply black swan? What do you mean by apply black swan?
What are you talking about?
The black swan argument. Or
Mr. Sensible did that experiment. He showed
the
how
black
it works.
swan argument.
Yeah,
the fact that you had refraction over just 9 miles.
No, it has nothing to do with refraction. This has to do with a geometric.
Of course. There's a reason why there's no 100-mile black swan, right? Because we've got, like, you can go on the coast of UK, which has the biggest wind farm in the world, set of wind farms in the world, and there's nobody taking pictures of wind farms 100 miles out, even though they would be clearly visible on a flat Earth. There's nobody taking pictures of wind farms 100 miles out that you can see all the way down to the base of the pylon, which is wider, okay? There's nobody out there that has that picture. There's a reason why the black swan is only 9.8 miles out, not 100 miles out, because that's the very limits of extreme refraction. That's as far as extreme refraction will ever take you. You can never go to 100 miles and not obscure any of the wind turbines.
Well, I've been told that with enough refraction, a powerful enough telescope inside the globe model, you should be able to see the back of your head.
With enough refraction, that could never ever materialize in reality.
Yeah, but hypothetically, right? If
if you could create a medium that have the refraction coefficient that you would need, yes, it would be possible. But in reality, that refraction coefficient is never ever realized anywhere on Earth.
See, that's the problem. When I look at black swan, I can understand it is a geometric, logical syllogy or whatever. So at some point, it gets so derailed because people when they hear it being applied to the Earth, somehow now the Earth can't be geometrically tested. But at the same time, it is geometrically tested by windmills or something like that. So I'm like, which one is it? Can the Earth be geometrically tested or not?
It can be, and the black swan simply shows how 1 foot off of the water under high refractive conditions, you can see beyond about 9 miles or so, whatever that is. That's all it shows.
Okay, so now I would say, if I can hypothetically, do the same thing with the Suez Canal, with no refraction, just looking straight out, you would be able to see the other side of the Suez Canal.
No, you won't be able to.
Because I can show you that it's basically you have the atmosphere is stopping your view. Like the same way if you dive underwater, you can't see very far underwater. Like
the atmosphere doesn't obscure ships from the bottom up. That's not how it works.
Yeah, but people have shown different experimentations with this, that the way that a far enough distance away, the horizon and the sky blend together. They form a horizontal apparent line.
That happens on both the flat Earth and the globe.
Yeah, I got you, and that's kind of where I'm getting at with this. So if you could see with enough clarity and a powerful enough telescope, and you keep zooming in, maybe this isn't refraction at all. It's just that a limited vision that is making it seem like things are disappearing bottom up, but they're not.
That wouldn't happen. That's just not how optics work.
Well, okay, then I guess can we go back to experimentation on that? How would you experiment?
We'll just go to you understanding that no amount of atmospheric interference, the fuzziness, the that kind of diffuse vision isn't going to obstruct something from the bottom up.
Well, yeah, but I can show you that it does actually.
No, you actually can't. We've been through this for years now. Flat earthers have never been able to show that the atmosphere or perspective can make things disappear bottom up. They've never been able.
Here's one I like right here, and I've done something like this in my own house. You can see clearly. I mean, the table one gets shit on quite a bit because they say that the camera is below the table.
Yeah.
So this one here shows a solid wood floor, and if you put the camera right on the floor, you can see the army men and the cannonball or whatever that's supposed to jelly bean or something. You can see that they do disappear bottom up.
Yeah, because no floor in your house is perfectly flat. There's no such thing as a flat floor in a house.
You have to show that it's perfectly flat.
Yeah, so if you put a level
it to be
here,
perfectly flat, and it would take a very small deviation. I mean, tile guys always complain it's hard enough to find a floor flat enough because nowadays the trend is large format tile, and very rarely is the floor in a house flat enough for large format tile, which requires a much flatter floor than houses are built to. Which is why they have to run. Which is why they have to run self-leveler to correct that.
Yeah, that's why right here with the molding, or what you call it, the shoe, right? You call that the bead at the bottom, the shoe. That's why you cover that up, because it's supposed to be like a finishing
base molding.
Yeah, like a finishing strip. So you don't see
there's no floor. It doesn't matter if it's slab, if it's slab on grade or raised foundation or second floor. You're never going to find a perfectly flat floor for this type of observation, where you're not going to obscure a few millimeters of the bottom of the thing, because floors and houses are not built to that level of flatness. There's no reason to.
Okay, well, how about if you do with specular reflection then? If I want to say the surface of the Earth is curved or flat, how about this right here? Is this possible on the curved surface?
You can do this. You can take a mirror. You could take any mirror, and you could create a backdrop of something that would represent those buildings, and you can put a curve in that mirror, and you'll see the same thing. Even though that mirror will be probably curved 100 times more than the surface of the Earth is curved, you'll still see the same thing. To get the type of angle of incidence to where those buildings would somehow be obscured by the curvature of the reflection, you would need a crazy amount of curvature. You're talking about 1 degree over 69 miles. In that picture, you're not anywhere near 69 miles. You're only, a few miles away from those buildings. You're talking about a tiny quantity, right?
So it basically be the uncontrolled variable, because the quantity is so little that this experiment would not be.
No. Yeah, you could test it yourself. You could bend a mirror. You could do this experiment with a mirror, and you could put a bend in that mirror that would represent hundreds of miles on the Earth, and you would still be able to perfectly see the reflection of the objects.
Crit, the test. I'm glad you said that, by the way, because there's a team of people on here, a team of one, because it's me, and we're planning to do a test with GPS, like accurate GPS. It's like accurate within a centimeter. And so you could take, like, say, the 4 corners, or the 8 corners, 8 corners of a building, the 4 on the base and the 4 on the top of the building, and you could get all 4 of those points and make a 3-dimensional rectangle. And you could take a city that's 69 miles away, do the exact same thing, take the 4 corners of the space, 4 corners of the top, and make another rectangle. And you could compare those 2 rectangles, those 3-dimensional rectangles, rectangular prisms, and see what the angle between them is. And I would assume that it's 1 degree, but this sort of thing can be measured.
Oh, that's interesting. When you get finished, it'd be good to see. Okay, that's what I'm talking about here. That's what I wanted. I would hope anyway. I'm not going to say I want something, because you want, and the haters out there will do the opposite. I would like to see this conversation kind of come back to that, people doing observations and stuff, and thinking about these things, and actually be able to hear each other out, instead of like just keep dropping excuses. Like somehow all you need is an explanation. As long as the explanation fits someone's narrative, it's it gives a stamp of approval. Because that to me isn't science. That's globalism. Then that's just people pushing an agenda and trying to the narrative.
That's been tried. So, for instance, Bev is in the text chat, and he's been challenged to actually do an experiment, and he's never going to do it because he doesn't want to. Flat earthers have been asked to do experiments, and they won't do them.
I gave you today multiple experiments that I've done.
You've also been asked to define the words you use when you use them atypically, like globalist, which you never do.
Yeah, we went over globalists already. Why are you trying to derail the conversation?
You just used it again to different people who weren't in the previous conversation.
So you know exactly what I mean, right?
No, I still don't know what you mean.
I've talked to Crit about this a long time ago. I've talked to Crit about this a long time ago, and the truth is that globalist means something totally different, but Crit uses it in the same way that other people use the word globers. So when he says globalist, he means globers.
That's not what he posted this morning.
I don't like
the whole idea of someone who's controlling money, power, people, places. And then later in the day said, oh, yeah, well, no, I actually meant people who believe in the globe. So which one is he using now? I don't know.
Okay, well, just put yourself on mute then and just listen. And maybe you'll figure it out.
Just say what you mean.
Okay, generally what I do, I don't try to make words up. Okay, I'm not going to be like ballers or globies or globeheads or globetards or globbies or global or whatever you want to say. Okay, those seem very odd to me. Okay, for some reason I heliocentrics. That's hard for me to say, so I don't really like to say the word heliocentricist. It doesn't flow out the tongue very well. So just the word globalist, it's someone who not only you could say believes that the Earth is a globe, but advocates for a globe reality. And so a lot of times they don't use science, logic, or reason. They use control. Because at the end of the day, a lot of the globalists don't really care what the shape of the Earth is. They just want to not be flat. And you'll hear them say this a lot. Yeah, the Earth is not flat. And I'm like, okay, fine. The Earth is not flat. What is it? It's not flat. Okay, fine. What is it? It's not flat. You get stuck in this. Yeah, so, okay, sure, it's a globe. And then you ask people to define it. Define this, what you mean by globe. And they always get back to, well, it's not flat. It's a circle, or it's a ball, or it's a pear. Well, these are all different things, okay? So which one is it?
You can look up WGS84 if you want to answer to that question.
So that's the model that you like to use, the WGS84?
So Crit.
People have taken effort.
Brenda, do you know what he's talking about when he says globalist now?
Okay, so Crit, the way people use words is they sometimes mean things really generally. So if I say the Earth is a globe, or even if I say it's a sphere, I don't mean it's literally a sphere or a globe. I just mean it's just kind of generally round in shape. And then when you ask further questions, they'll get more specific. Oh, they'll say, oh, okay, well, it's an oblate spheroid. And then you can get even more specific. It's an oblate spheroid, but it's a little bit heavier in the southern part than it is in the top part. So it'd be kind of, if you exaggerated, a pear-shaped, even though it's not really pear-shaped. And even though if you were to see the whole Earth from space, it would look like a perfect sphere. But when we measure it, it has these measurements. And that's how people use words. They are not being anal or very perfectionist about their language. They just use them in a general sort of way.
Wow. Just wow.
Yeah, I'm trying to process that right now, Brenda.
Yeah, people use words in a general way, and then when you ask further, they will narrow it down. That's how people use words in a lot of contexts.
So when you say pear, you actually mean a globe. When you say geoid, you actually mean a perfect sphere. I get it.
No, that's exactly what I didn't say.
There's a guy on Facebook, a group I was in for a long time. It's like Mark something or another. And he was a surveyor, an engineer. And he broke down the WGS 84. and he did a 3D representation of it. And I'm trying to look for where he saved it, but it looked ridiculous. You know, it was like it wasn't even a globe or a sphere or anything. It was just a glob of shit. It looked like a kid playing with a Play-Doh.
That's because it was exaggerated.
Wow, they just keep upgrading it.
If Crit would just use the term globalist and then quickly addend it by saying, when I say globalist, I mean people who believe in the globe, we'd be fine. But he's incapable.
Okay,
of
cry
doing
more. It's okay, cry more.
It's not a cry. It's asking you to be reasonable and communicate effectively.
I need somebody help.
I'm just gonna be like, here, I did some like just Google searches, but this is kind of what he came up with. It showed this right here, and it was just like ridiculous.
That's highly exaggerated,
Yeah.
of course, isn't it? Right? So it isn't that really ridiculous. It's just exaggerated, and you're just not able to understand the difference between an exaggeration and something that's more realistic.
But there's a problem here because this model cannot be used to predict anymore.
Sure it can.
Not 3-dimensionally. It can be used.
Why not?
It can be used 2-dimensionally, but not 3-dimensionally.
Why?
Because look at this line. The green line would be what you would call reality, but the red line is your measurements. That is fucked up.
Why is the green line reality?
Well, supposedly that would be the ellipsoid, or what the real.
It's not.
That would be a perfectly shaped ellipsoid, is what that's
Yeah.
supposed to be.
Yeah, the Earth isn't a perfectly shaped ellipsoid. It's a geoid.
Okay.
The red line is very close to reality. That's what the red line is. You've got it backwards.
Yeah, but look at if you follow the red line, even for the water, that doesn't make a whole lot of sense.
The geoid is not the actual shape of the Earth either.
Oh, okay.
The topography is going to be the most accurate.
Well, yeah. Okay.
To say the Earth is a geoid is just so strange to me. The geoid is a particular representation of certain characteristics, qualities of the Earth. But to say the Earth is a planet, and the shape of the Earth is not the geoid. It's not the true shape of the Earth or anything of that nature.
So you would say its true shape is its topography?
Well, yeah. That's its true shape, sure. All these other things are for references.
Right. The ellipsoid is if it was a perfect, curve that was not deviated at any point. The geoid is a representation of where the, gravitational attraction or the mass is more based on density of the rock and density of the ocean and all that kind of things. And the topography is the physical feature.
Okay, so here, let me post an image here. So something like this then, right? Let's see if that
Drax
comes in.
posted one of the simplest definitions of the geoid in the chat.
SD has the brand new memes, Dan.
Okay, thank you, Wirus. Thank you.
So yeah, this is kind of what I was getting to here, where using astrophysics, the image on the right would show you that mountain with the H next to it, with a big letter H, compared to a small letter H, that you would see a gas pressure gradient different than small letter H.
Where are you getting gas pressure gradient involved with this?
Astrophysically,
What
the
is this?
closest center of the Earth.
Okay, that's not a sensible response. So it's hard to understand what you mean.
Okay, I'm basically citing Tyson, Neil deGrasse Tyson.
That doesn't make it astrophysically. Come on, Crit. You can do better than this. I know you can.
No, hold on. I'll get the citation here. Give me 1 second.
Things don't work by citation.
You know he can't do better.
He is a flatulist. So what can you say?
Well, the Dead Sea is below sea level, right?
Sure, I suppose. I think
Not
it is.
below
Yeah.
Dead Sea level.
It is. Dead Sea level. That's funny.
Yeah.
But the pressure above the water at the Dead Sea is probably going to be above atmospheric pressure. At least other places.
How much?
Not by much.
Death
It'd
Valley's
be the same.
below sea level, isn't it?
Say again?
Death Valley's below sea level, isn't it?
Yeah, Death Valley as well. There's another place I was going to mention. You would imagine that the PSI is going to be like a little bit above 14.7 or whatever.
Nominally, yeah.
If you're using gravitational potential.
Hey Kosho, I just looked it up. It says Death Valley is 282 feet below sea level and has an atmospheric pressure of 14.9 psi.
Ooh,
I never.
Better
Equal to measure something.
Better not go there. You might get crushed to death.
I want to visit Death Valley. It's like maybe 4 hours.
Just you said you have a friend who lives there?
No, I want to visit.
Oh, is that in California or is that in Nevada?
What's the Baker? What's the visit? It'd just be interesting to see the sliding rocks.
Well, I mean, if I live close to there, it's cool. You'd be cool to do a test there, man. Like when you use like the app that has the Wow, my microwave goes crazy, man. But you would use that app that gives you the pressure. It's got a barometer.
Better take care of it. You're going to burn your house down.
Yo, Pyro, increase your FPS, man.
Wouldn't you want to visit the world's hottest place?
It's not. I don't think it actually has the record, man. But I've heard it had the record, but there's places that have been way hotter.
I want to visit the world's hottest woman, not the world's hottest place.
Wouldn't it follow that the world's hottest woman would be at the world's hottest place?
Not at all.
Yeah, VD is a placist.
Take Stacy to
Why are people messaging? Somebody Pure was messaging about Stacy about. I don't know. It's really weird. I haven't been here all weekend. So
Kosho, fucking. Stacy said she was actually forced to flirt with you by Riggs.
Okay, here I got it.
Same here.
Yo, Pyro, can you increase your FPS on the stream?
Jim Panda made me flirt with her, man. I was the honey. I was doing a honey dick.
Yeah.
Okay, here it is right here. It says astrophysics. We don't care about sea level. And if you look at the whole video, he breaks it down.
It's probably my upload.
You and Dross specifically.
Yeah, I don't think that as an astrophysicist they would be concerned about the sea level on Earth. I don't see why they would be concerned about that.
But that's what we're talking about with gas pressure gradient, though. It's astrophysics, right?
No,
not really.
What the hell?
Geophysics. Metrology.
Jumping ship again.
When you're talking about this gas pressure gradient and then going out into space, where it's a near perfect vacuum, but it's not.
There's nothing astrophysical about the troposphere. I can say that with great certainty.
Or the Kármán line.
Fuck's sake, Crit.
Right, is that the Kármán line is based off astrophysics?
Dude, we were talking about air pressure on mountains before. Now you're out to the Kármán line.
Yeah, because we're talking about gas pressure gradient.
Because he doesn't have a clue.
There's a gradient from sea level to the fucking mountaintops. You don't need to go to the Kármán line to get a gradient.
But you want to talk about
Kármán
astrophysics.
line is an abstract construct to allow paper pushers to get a grip on what is or isn't in orbit.
I want to be a flatulist, too.
Sorry, I got unmuted.
Fuck all to do with any real physics.
Oh, experimentation.
Bon Jovi, did you get the note about a hot mic getting
Yeah,
intel?